Sixth graders, this is Miss Young. This is a video going over your Chapter 4 practice test. Normally, I wouldn't want videos to be long, but this is an entire practice test, and in class, this usually takes you a full hour. So I'm going to try to go somewhat quickly, so you might want to pause it as you go, or if you don't need help with all the questions, you can skip around. Okay, number 1, George flipped a nickel 35 times. It landed on heads 12 times. What is the theoretical probability of landing on heads on the next flip? Theoretical is if we didn't flip it yet. It's what should happen, but what should happen doesn't always happen. So we have heads and tails as our only two options. So it's half the time. So you could say there's a 1/2 chance he lands on heads, or 50%. Experimental probability is what actually happened. So maybe you're trying to see if there's something unfair about the coin or something like that. Your denominator should be your number of trials, the amount of times you flipped the nickel. So that's 35. It landed on heads 12 of those times. So you would write 12 as your numerator. So those are different answers for theoretical and experimental. Number 2, Mrs. Houston's purple bag contains 27 marbles. If the probability of reaching in and pulling out a blue marble at random is 4/9, how many blue marbles are in the bag? Fill in the blank and justify your answer. So there's 27 marbles total. So we put that in our denominator. The portion of marbles, of blue marbles in the bag, should be equal to 4/9. So we're looking for an equal fraction. We are multiplying by a giant 1 to create that equal fraction. So what we're asking is 9 times what gets us 27? That's 3. To make this a 1, we need 3 in the numerator. 4 times 3 is 12. So there are 12 blue marbles in the bag. At the right, so right here, is a sample of the portions web. For each one of these problems, give the other 3 parts to complete the web. So for this one, we're given the percent. Remember that percent means per or out of 100. So if we're making it a fraction, we could just write 35 out of 100. We sometimes simplify fractions. It doesn't ask us to right now. Then it has a decimal. We could write it as 35 hundredths. The word you say for place value with decimals, you're always saying where the last number is. So this is the hundredths place I drew an arrow at. So in words, there's actually a few ways you could write it in words, but I would just write here 35 hundredths. You could even write 0 and 35 hundredths. There's a few different correct answers. 3/5 as a decimal. So decimals, it helps if you can write them as tenths or hundredths. So I'm going to do this off to the side, 3/5. I want to do tenths. Again, I'm using a giant 1 to come up with an equal fraction. 5 times what gets me 10? 2. 3 times 2 gets me 6. This is 6/10. So I'm going to put a 6 in the tenths place for my decimal. Percent means per 100. Let's say I want to make that out of 100. Since I already have it in tenths, that might be easier for me to think through. 10 times what gets me 100? 10. And again, we have a giant 1 because we're looking for equivalent things. So 6 times 10 gets me 60 out of 100, 60%. In this one, I would say 6/10 or 0 and 6/10. So with my words, I'm choosing to write the decimal version of the words because that's something we practice. This one gives us the decimal. When you say decimals out loud, we say the number past the decimal, like a whole number. We say 72. And then the last part of a number is in the hundredths place. So we say 72 hundredths. Hundredths. Okay, so that's 72 out of 100. That fraction could be simplified. It didn't ask us to right now. Percent means per hundred, so 72%. All right, let's move on. Number 4. A lot of people get least common multiple and greatest common factor mixed up. So let's make sure we remember the difference. Multiple is like we have many of something. So we have like 1 9 and then another 9. We have multiple 9s. 27 is another 9, 36. And then we count by 36s, but we only have to say the first number. The smallest one that they have in common happens to be one of the numbers. Now let's do our greatest common factor. So remember we talked about a factory has lots of parts in it when you're making things. So we're breaking these numbers into parts. So to make 9 with multiplication, we could have 1 times 9 or 3 times 3. And those are our only ways to make 9 with multiplying with whole numbers. With 36, you can go through, and I like to just say in my head, does 1 work? Does 2 work? Does 3 work? And that takes a while. But if you do it that way, you get used to the patterns and you get quicker at it. So let me just list all these. If you're stuck, you can look at a multiplication chart. 2 times 9, 3 times 12, 2 times 18. Okay. So those are the factors of 9 and 36. I'm trying to find the GCF, the greatest common factor. The biggest one they both have is 9. Okay, in this case, the LCM was one of the numbers, and the GCF was one of the numbers. That does not always happen. Okay, back to probability. There are 36 green, 22 white, 30 purple, and 14 blue gumballs in a gumball machine. Sherry wants a white or green gumball. What is the probability of a white gumball? The kind of annoying part of this is that we have to add up the total of the gumballs in the machine because we are doing the theoretical probability. So we're saying in theory, what are the chances of getting a white gumball? What portion of the gumballs are white? So we need to add up these numbers. And a lot of times when we're focusing on something new, like probability, our brains put so much power into that, we forget how to do things or we make adding mistakes. So be really careful with adding. So 6 plus 2 plus 4 gets us 12. 1 plus 3, 4, 6, 9, 10, 102. Yep, okay. So that's our denominator. That's our amount of possibilities. There are 22 of those are white. That's the portion that are white. Green, there are 36. Of the 102 possibilities, there's 36 ways to get green. Now it says white or green. So she likes both those flavors. It doesn't matter which one. So if we add those up, there are 58 gumball types that she really wants to have. So it's 58 out of 102. Notice in probability, when we have or, that results in adding. Okay, rolling a fair number die or cube. So that would be, and we're thinking of the 6-sided one. List all the outcomes when rolling a fair die or number cube. So, and I think I have a mistake here. I should have. So all the possible outcomes, that's everything that could come out of the situation, every possible result. We could get a 1, we could get a 2, I'm drawing what they look like on the dice, a 3, a 4, a 5, or a 6. So we listed the outcomes. That's 6 possible outcomes. What is the probability of getting a number less than 5? What I would do is list my outcomes again. My denominator is my possibilities. There are 6 possible outcomes. I'm going to circle all the numbers that are less than 5. Is 1 less than 5? Yes. How about 2? Yes. 3? Yes. 4? Yes. Is 5 less than 5? No, it's equal to it. So there are 4 possibilities that are less than 5. So 4 out of 6 possibilities. And we could simplify that, but it didn't ask us to, so let's go on. Amy reached into a bag, recorded the color of the tile she picked, returned the tile, and drew again. These are the tiles she has drawn so far. So she's got some red ones, 1, 2, 3, 4 red ones. I'm assuming we're going to need to know how many of each. So let's make a list. So red, we have 4, blue, 1, 2, 3. You can use colors on the test if you have them. Green, there's 2. And I want to have a yellow. Yellow, just 1. So total, that is 1, 2, 3, 4, 5, 6, 7, 10. That's a nice number to have. What is the probability of drawing a red tile? So this is theoretical because we haven't done it. We're seeing what's the likelihood. 10 is our denominator because that's our possibilities. What portion of them, what amount of them are red? 4 of the 10s. What is the probability of not drawing a blue tile? So let's think of all the ones that are not blue. Okay, the 4 red are not blue. The 3 blue are blue. The 2 green are not blue. And the 1 yellow is not blue. So altogether, the not blue ones, oh my gosh, it won't let me change the color. Altogether, the not blue ones are 4, 2, and 1. That is 7 that are not blue. So 7 out of 10 are not blue. If she draws 70 more times, how many times did you expect a green? Let's first think about what portion of them are green. So 2 are green out of 10. So expect is like theoretical. We don't know what's going to happen. But if 2/10 are green, we expect that same portion to be green out of the 70. So we need an equivalent fraction. And again, a giant 1. Do you notice how many giant 1s we've used? It's a big theme here. And recall that it's called a giant 1 because the numerator and denominator match. Like 2 out of 2 maybe. 2 out of 2 is 1 whole. Giant 1s are always 1 whole. Going back to this, 10 times what gets us 70? 7. Okay, our numerator has to be the same for it to be a giant 1. 2 times 7 is 14. So that's how you show your work, but we would say 14 times we would expect a green. Now, if we actually do this experiment, will we get exactly 14? Probably not, but it's likely we'll get a number close to 14. Okay, now this is a different question. Write 2 fractions equivalent or equal to 2/7. So we get to be slightly creative. We're picking a giant 1 that we want. If I did 1/1, it's going to just be the same numbers. So I am going to pick the next smallest number because it's easiest. I am going to do 2/2. And I get 4/14. Part of me wants to just pick 3 next. But I'm going to pick 10. That's a pretty easy one too. Okay, 2 times 10 is 20. 7 times 10 is 70. So there are infinite possibilities you could have for this. So there are wrong answers, but there are like a ton of right answers. Number 9, using the fraction shown below and a giant 1, again, we have a giant 1, create a fraction with a numerator of 45. So I'm going to zoom in. We have 5/8. We want an equivalent fraction. An equivalent fraction with 45 in the numerator. Okay, because we want equivalent, and I think I might have accidentally deleted the word equivalent. We want to multiply by a giant 1. 5 times what gets us 45? 9. 8 times 9 gets us 72. So that's the fraction. This one, again, we have 5/8. We want a denominator of 48. So denominator is the bottom number. I don't know why the pen thing was changed. 8 times what gets us 48? If you're really struggling, you can use a multiplication chart to help you. 8 times 6 gets us 48. So we fill in 6. 5 times 6 gets us 30. That is our answer.